Next stop, Public Square.
Let's start with that shot. Welcome to Public Square. Today we'll talk about sunshine and what's being done right here in Cleveland to harness the sun. The sun, the most abundant, non-depletable source of energy in the universe, is being harnessed to produce electricity. Cleveland's Lewis Research Center has led in the development of solar cells for use in the space program since the 1960s. Today, NASA's solar electrical research is being directed to more earthly uses. The remote Indian village of Stuchulig in Arizona had only a few small diesel generators as occasional sources of electricity. With a population of only 95, the village was too far away from a source of conventional electricity to make a connection financially possible. Clothes had to be sewn and washed by hand. Food and medicine could not be stored because of the lack of refrigeration. But with NASA's help, Stuchulig became the first village on Earth to get electricity from the sun. Today, the electricity generated by the sun is stored in batteries to provide light and running water day and night. Clothes are made on a modern sewing machine, and food and medicine can be stored in a community refrigerator. Bill Bufano, chief of NASA's Solar Project Section, told us more about solar power.
This is a solar module consisting of a number of solar cells connected in series that produces DC power when illuminated by the sun. The modules consist of a number of cells which are normally made of silicon discs, and each disc puts out a half a volt, and the amount of current depends on the area of the cell. And the rest of the system is made out of glass and fiberglass, things of that nature.
How long has this research been going on here in Cleveland?
We started back in about 1970. We've done work, of course, previously for the space program, but for terrestrial applications, we started in the early 70s. With the advent of the National Photovoltaic Program in 1975, we began working with the Department of Energy, and more recently with the Agency for International Development, which is our foreign assistance agency.
What foreign countries are you working in now?
Probably the number runs up to 20 or 30, but the major ones are Upper Volta, Africa, Zimbabwe, Kenya, Ecuador, and Guyana.
Is that very similar to the project in Arizona?
No, not necessarily. There are exceptions in Tunisia. I didn't mention that. We do have a very large village going in the next year, but the other systems are small medical clinics for uses in vaccine refrigeration and that sort of thing. Communications, we're going to be powering some Earth stations. I think that's a very exciting applications where the Earth stations will be in very remote areas where they can't now reach them through any other way.
We have heard so much about solar power over the years, but it never seems, the time has never seemed to have come. It hasn't reached its prime, if you will. Why not?
Well, as far as solar cells are concerned, we've made tremendous gains, and I think we're going in the right direction. I think in the next 10 to 20 years, it definitely will be an option for many applications. We have to remember, in this country, we have a magnificent grid system. We don't probably appreciate how good it is. But in remote areas of the world, and don't forget, 3/4 of the population of the world lives in developing countries, they don't have access to electricity. So very likely, the introduction of this technology will take place in the developing world. And probably by the year 2000 or 2010, when we begin to get into probably a more serious energy problem than we're in now, we will see this being used more widely in the United States.
Why are we so involved in the underdeveloped countries as far as solar power is concerned?
Well, I think we have to keep in perspective what we're trying to do there. There are two objectives. One for the Department of Energy is to try and enhance our marketing capability overseas and to try and get some visibility and experience, because frankly this is, export marketing is an important thing for the United States. For the Agency for International Development, we're trying to improve the health delivery, the education delivery, communications, not so much to displace energy, but to help them improve their standard of living and well-being of the people. And I think this is a good way to do it, bringing technology out into the rural areas. And frankly, some of these things are affordable. today for small applications.
With what we know now, how does the cost of solar power compare to the cost of electricity or natural gas?
If your needs are less than about 5,000 to 6,000 kilowatt hours per year, again, what an average family uses, then solar cells are very likely cost-effective on a life cycle basis. In other words, if you amortize the cost over the life of the system. As the costs come down further, and they will probably drop by a factor of 10 in the next 5 to 10 years, of course, more and more applications will open up, and of course, there'll be more situations in which it'll be cost-effective.
What about Cleveland as a feasible place for solar power?
Again, if you're talking about small applications where you have to drop a line or bring in power from some other method, it would be cost-effective. But we have power everywhere, practically, here in Cleveland.
Do we have enough sun, though?
Yes, in a sense that the solar cell power produces, the solar cell itself produces power whenever a light impinges on it. Of course, the more sun you get, the more power you get. But it's not like a solar collector that you use to heat water or heat air. That needs a certain threshold temperature, and that doesn't start until 10, 11 o'clock in the morning. These things will start producing power as soon as the light falls on it early in the morning. So they are very useful for charging batteries, for example, if you're in an area where you don't have the grid. And so it is potentially useful in Cleveland.
Bill, we see this experimental work going on, and we also see so many people putting, we've done news stories on people who have put them in their houses. But I guess the question that I really would love to know is that we've heard so much about this. Is this going to be the power of the future? Certainly sun is free.
I'm convinced, and again, the question is when. I'm convinced that at some point beyond the year 2000, there probably will be a significant amount of power generated by solar cells. And when you look further into the future, you find there isn't too much else in long-term planning and the futuristic kind of approach to civilization, that this has to be one of our major sources of power. And along with it will be a new way of using electricity. Not the way we use it now, but a very frugal and very thoughtful way of using electrical power.
Even on a partly cloudy day in Cleveland, this single solar panel provides enough electricity to run a grain grinder, powered by an electric motor, or to pump enough water for people and cattle and irrigation in a remote village. Even now, the cost is surprisingly low, about $5,000 for the solar panels and either the pump or the grain mill. With NASA's continuing research and development, the future of solar electricity looks bright, with higher efficiency and even lower costs. Fascinating, isn't it? And it's all happening right here in Cleveland. We'll be back with more of Public Square in just a moment. Stay with us.